Authentication and authorization testing. So authentication and authorization are another great function that modern web applications provide to us. Authentication is the process of proving the identity of the user or any entity. So that means that users prove that they are who they say they are. And then the application allows them to view and interact with the content, right? Nowadays, especially, authentication mechanisms are not just used for accessing content. It's also used to personalize content of just about any application. So your account on a web application is starting to be a strong vector that corresponds to your real-world existence, your identity. So guess what? This makes the authentication, well, of course, way more important today. But for you and me, there are a wide range of technologies available to implement authentication mechanisms. So far, HTML, form-based authentication, is the most used one, and in general, web applications authenticate users with a username and password. But this can vary due to the application's security needs. So then, after authentication, the application grants permission to users in order to perform several actions, such as viewing files, executing something, or whatever it may be. So that's why in this section, we're also going to cover authorization problems. Okay? Authorization is the process of determining what resources a user, service, or application has permission to access. So it can be defined as an access policy of resources. Authentication and authorization are closely related concepts, but they are not the same. The first term proves the identity of a user, website, or any entity in any context. But authorization verifies the privileges granted to the authenticated identity. So, for example, once you log into your bank account, you're only authorized to transfer money from your accounts, for instance, right? If you can do it with another account, this means that there's a serious authorization problem. So in this section, we're going to talk about password policy problems, password-related issues, and brute forcing passwords. Also, some problematic usage of CAPTCHAs. And then we're going to cover some authorization problems. Password policy problems. Now, passwords are the key elements of an authentication system, right? They're like the keys to open a door. So the application should have a strong password policy. But you do have to be careful. I don't mean just password complexity with the word policy. Password policy is way more comprehensive. The complexity is just a property of this policy. So a password policy sets how to transport and store passwords as well. All right, so here as pen testers, we got to figure out three things: password complexity rules, password transmission rules, and password storage rules. So the last thing is basically how the passwords are stored on the back end. So it's not directly a pen test aim, but passwords should be salted and encrypted and then stored. See my meaning? Because even you cannot bypass the login mechanism, but you can reach the database over an SQL injection. And if passwords are not stored properly, they're going to be dumped. But we're going to talk about password complexity and transmission. So the first thing that we should check is to see if the target has a policy or not, because this is going to shape how to attack the login mechanism of the application. So if the target has password complexity rules, we should generate the dictionary based on these rules. So now go to Kali and open up your terminal, and we're going to use Crunch to generate a password list. And simple usage of the help screen is printed. So Crunch can create a word list based on, well, criteria that you specify. For example, if you type crunch 44AB1, it will print 4 character words to the screen by using A uppercase B1 and. So now let's have a look at the man page of Crunch. Crunch has a well-planned man page with examples. So scroll down to see some example uses. And you can quit from here. So let's use some options. So it generates word lists based on a character set. And you need to provide Crunch a char set to start. So thankfully it has its prepared list in this directory already, and then you can choose one of them or add a new one if you want. Okay, type crunch88/user/share/crunch/charset.list LALPHA and hit enter. So it's going to produce a long output, but I'm going to stop it here. And now I'm going to provide my custom char set. So it's a long output, and I'll stop it here. Okay, so let's have a look. As you can see, the output contains only the characters in my set. So then you may want to add some special characters like double quotes or spaces. And it will cause an error like this if you do that. So you're going to need to escape like this. Or you need to put your set in between double quotes. So also, I'm going to add a space like this. And output is very long, so I'm going to stop it here. So you can see that Crunch is a very powerful command line word list generator. So it helps us to play with characters. So by typing this line, T, the parameter will produce a special output. And the first two characters will be lowercase, the next two characters will be uppercase, next two will be numbers, and then the last two will be special symbols. Now, the order in which you specify the characters you want is important. So it means that you need to specify your char set's order as lowercase character, uppercase character, number, and then symbol. Now, if you aren't going to use a particular char set, you must use a plus sign as a placeholder. So let me just add a plus sign instead of CD and change it here to lowercase. So if I use a placeholder for uppercase letters, then it will use all uppercase letters in the English alphabet. Okay? So we can also limit the number of duplicate characters. That you just use a D parameter to add a limit. And this will limit duplicate lowercase letter to 1, which means the letter will not present after the same letter. Also, we can expand this to uppercase letters as well, numbers and symbols too. So Crunch can also print the list after a specific word. So using the S parameter with the word ABDC12, it will trim words before ABDC12. And using the E parameter, we can trim the output from the end like that. Then the output from Crunch can be sent to the screen file or to another program. Now, typing the O parameter, we can then save the output to a file called Wordlist. And I'll show you the generated output. Okay, so besides having a good password policy, the application can still have authentication issues. One of them is default and weak credentials. And it's very common to see these values in pre-configured application platforms, hardware's web interfaces, and in internet environments. Just for the sake of usability, they all come with default usernames or sometimes default passwords or both. And generally, companies have a standard structure of email addresses or any other text used to define a user ID. So what this does is it helps us to predict username values and even passwords. So what I'm saying is don't even hesitate to use the default values while testing. And then another thing in a policy is to identify how many passwords are transmitted. So even by having a strong password, if it's not carried securely, it can be exposed. So while transmitting a password, the application should use encryption. And this is, of course, HTTPS. But not only passwords, but any other sensitive data, such as payment information. So this brings us to yet another problem that we're going to cover in session management. HTTPS shouldn't only be used on login pages, but the entire application. So go to Kali and open up your terminal. And we're going to capture network traffic to watch for credentials that are transmitted. So open up Wireshark by typing, and then open up your browser. I'm going to just dock it over here to the right side and go to the BWAP login page. Now, before you log into BWAP, start capturing the traffic on your network interface. So in my case, it is ETH1. So I'll choose it and start to capture by clicking this icon on the toolbar. And then go to the login page. Enter username and password, hit login button. Okay, so we logged in. So now let's go to Wireshark. Now, here's a place that you apply display filters on the capture traffic. So simply type HTTP to view HTTP traffic. As you can see, the first line is the login request that we sent. Click it to choose, and below you can display details about this line. So under this node, there are HTTP-related data. And under this node, you will see the form data has been entered. And you can see it is in clear text. So anyone on the same network can sniff this data. You can also right-click on this line and follow the TCP stream, and then view the HTTP traffic data as we see it in Burp. Okay, so now I'm going to close this window and stop capturing. Let's return to the browser again. This time, go to an HTTPS web application, and I'll just open the Twitter login page. And I'll get me a fresh capture. Okay, so enter in some login information here and log in. And you see Wireshark again is capturing the traffic. But this is not raw HTTP. It is encrypted traffic. So I'm going to filter SSL only traffic. And you can see the protocol. It is TLS version 1.2. So this means the data is encrypted. Choose any line. And from the below pane, open Secure Socket Layer node. And here is the encrypted application data sent over the network. So if you follow TCP stream, you won't see anything. So obviously the point here is, as a pen tester, we need to check if the application data is sent over a secure channel or not. All right? So now we need to report, and we can benefit from this finding as well. So another big problem in authentication is insecure login forms. There may be hundreds of ways to make a form insecure. So for these examples, I'm going to be in BWAP, and I'll go to Kali first and log into BWAP. And from the drop-down menu above, choose Insecure Login Form under the Broken Authentication section. And the default level is low. And it is rare to see the first two levels in the real world, actually. But I think it's a lot of fun. So let's try and solve them. Okay, so when I try to log in with the wrong credentials, I'm going to get this warning. So then we view the page source by right-clicking and scroll down to the login form source. So see, here is text with a white font color near the login label, and also another text with the same property near the password label. So if you mark here and here, you're going to display them. So I'm going to use these values. And it is done. We've just logged in. Okay, so that was fun. Let's choose the medium level. So I'm going to mark here, but there is nothing, okay? So view the page source again, scroll down to login form, and here there are no hidden values. But see over here, the submit button, have a look. You're going to see it executes a JavaScript function. Now, I think this is the first function that we've seen opening the source. So here's the function. I don't think it's very hard to guess, huh? It uses some of the characters in the string to create a password. And again, it's really a load of fun. To get the password from this function, just copy it and open Developer Tools. Go to Settings from here and check Scratchpad to enable the tab, and go there. So clear here and paste the function. I'm going to just zoom in a little bit here. Okay, so we don't need these lines. And to see the result, I'm going to add here return secret and an alert message to view the result. Okay, so let's run it. And it is done. What's this? Yes, we get the password. So, in case you think I'm joking, I'm going to use this. Okay, we're done. We've just logged in. Okay, so at last we're going to do a brute force attack. So let's choose the high level. So here's your new page and view source. If you scroll down, you won't see anything with the form. So, okay, let me just log in with some wrong credentials and see what's happening. Okay, you get the same warning message, invalid credentials. So now we're going to do the rest with Burp. So enable Foxy Proxy, then open Burp. And I'm going to arrange the windows. Now log in again. And Burp captures a login request. So send it to Intruder and Repeater to use later. And then forward the request. Okay, so open Intruder tab. Now there are 4 sub-tabs under Intruder. And under the Target tab, you can configure the target options. For example, you may force it to use HTTPS, and then go to the Positions tab. Then here you can configure where and what to brute force. So Burp heuristically selects some parameters to attack, but we don't need them all. So you can clear them, and let's just use only the password and username. So let's choose Cluster Bomb as the attack type. Okay, so we're done with this. So now go to the Payloads tab. Now, here's a place that we provide data or dictionary files to attack. So we can choose 2 parameters to attack at the same time. And here are 2 payload sets, which are available here, but we don't have any payloads yet. So let's create some payloads first. We can use Crunch, or we can try another as well. So in fact, open up your terminal and type CEWL. Seul is an other password generator, but it works kind of differently. So it'll crawl a URL and extract words to create a word list. So type CEWL --help to see options. Okay, then add W as a parameter to save the result, and the D parameter to define the crawl depth, the M parameter to define the minimum length of the word that will be extracted, and E for including email addresses. And let's include words with numbers. Okay, so I'm going to copy this URL and paste it here. Nothing to change. And hit enter. And it executes quickly. So here's a generated Wordlist file. Let's have a look at it. Now, it contains 44 lines. So I'm going to delete some of the entries because it'll take time to try every single one. So I think these ones are going to be enough. So now go to Burp Intruder, choose the first payload. Don't change the payload type. It's a simple list. Just come back here and click Load. Okay, so we load the first payload and choose the second payload. Again, load Wordlist. And Burp automatically calculates the requests that will be sent. And I think if we do this with a huge list, it's going to slow down our target network in our environment. So there's nothing to change here. Then go to the Options tab. Now scroll to grep match. So in this section, we teach Burp to understand when it is going to be successful or not. So then Burp will send each login request that contains values from our payload list and then analyzes the associated responses. And then that way, if Burp matches something in the response with these strings, it can mark that request for us. So these strings are not useful in our scenario, right? So I'm going to clear them. And then I'm going to copy this warning on the page and paste to add it here. And then I'm going to check this box to make Burp flag the resulting items containing this warning. All right. All right, so there's nothing more to configure here. So let's go up and start the attack. So this is the attack window. And we can wait a little bit for it to finish. And looky here, Burp flags all the result items containing this warning. Now, if a result doesn't contain this warning, it means that we're successfully logged in. You get it? So let's click this unchecked line. And below are the details of the request present. It tries bees and bug. So look at the response. Here's a successful login message. Okay, so obviously this is a very basic brute force attack to an insecure login form. Don't worry, we are going to do a little more advanced ones in the next videos, but you get the concept, right? So logout is another important function in applications. As a login mechanism, logout should also be done securely, but sometimes the application doesn't log out the user properly. And of course, this causes some serious privacy problems. There may be hundreds of ways to implement such an insecure logout function. So let's just have a look at one of them from BWAP. Okay, so go to Kali and log into BWAP. And from the drop-down menu above, open the Logout Management under Broken Authentication. Okay, so this is a sample authenticated page, and the default level is low. Now, view the page source to get some interesting information, if, of course, the page source has it. And there's nothing here. So when the link is clicked, a JavaScript confirmation dialog will appear. And then the application will redirect us to a new page, BA_logout_1. Okay, so now open Burp and activate interception. I'm going to rearrange my browser here for a better view. All right, enabling Foxy Proxy to send traffic to Burp. And now I'm going to click here to log out. Okay. And Burp capture the logout request. So let's forward the request. And we get a 302 redirection response. So it redirects us to another page with a location header. What is it? login.php. So that means that the application logout sends us to the login page. It doesn't log us out. So this is a general logout mechanism example. And I'm going to forward the next messages as well. And I logged out. So the login page opened in the browser, but do we really log out? Okay, so now move on to the back button in the toolbar, right-click, and you will see pages that we've previously visited and cached. As you can see, the authenticated page that we visited is right there. So if we go back, the page will be displayed. I forgot that Burp is in interception mode. So go forward, disable interception, disable Foxy Proxy also, and open the page again as we think it should. So now let's visit some other pages. And as you can see, we're still logged in. So even for the medium and high level, the application really logged out the user. But there are a few differences in the code. So now select medium. And I'm going to click here to log out. Okay, so I logged out. But when I press the back button, nothing happens. This means that the application did indeed log me out. And the same thing happens when I choose the high level. Okay, so let's go to the code and have a look, see what's happening. Now, I previously downloaded the BWAP application to Kali because sometimes I want to show you the code as well. So I'm going to open BA_logout_1 and scroll down to see the actual section of logout. Yeah, so it works based on the cookie levels. If the level is low, it does nothing. And that's why we can see the page by pressing the back button. And if the level is medium, it just destroys the session. Now, for logging out, it may be enough, but it isn't really secure, is it? Because the session-related values are still present in the session variable in memory. So this variable also needs to be assigned a null or empty value. And that is done in the high level, as you can see here. So this bug is directly caused by an insecure logout mechanism. But we'll be talking about session problems in the next section. I want to go on with a couple of other problems. So another implementation problem is weak password recovery or reset solutions. So let's say that you want to change your password. So here you should have a look to see if the current password is confirmed or not. And is a password change form akin to CSRF attack, which we are going to cover in the session management section. But the other thing is, well, that can happen to all of us. We all forget the password, right? I do. Sometimes. Now, what information is required to recover the password? So, here come the secret security questions and maybe second communication channels that proves the real user. And again, the application should confirm the recover request on a second channel. So open up Kali and log into BWAP. From the drop-down menu, open Forgotten function under Broken Authentication. So I'm logged in as the user B, and the level is low. Now, what I expect to see here is to learn my secret or password, because I don't remember. So the application waits for my email address. But there's a problem. What if I don't know my email address? So I'm going to check from my PHP, my admin interface, users table, browse the users. Okay, so this is my email. And I'm going to write it into the input field and click Forgot. And then it immediately prints it to the page. Okay, so you see that this is a bad implementation because it obviously holds the secret or maybe even the password in clear text. Not good. But you know something? You know what's really bad is when you write the email address of another user and you get the user's secret. So if you know the email of any user, you can learn their secret. It's just terrible implementation. So now let's change the level to medium. Okay, so I'm going to enter my user's email address. And this time it sends the secret to my email. Okay, so open up a new tab and go to mailinator.com. So this application provides disposable email boxes. You don't even need to create a real account. So just type the BWAP B into the open inbox for this user, and the first one is the latest message that's come up. So click it. And what do you know? Here's the secret. And it's still in clear text. So why don't we try other email addresses? BWAP user 1 and BWAP user 2. Go to Mailinator again. Open the inbox for BWAP user 1. Here's a secret. And open the inbox for BWAP user 2. You've got mail. So this is really good to send each secret to the real person, but the sensitive information is in clear text. Okay, so let's go back and open BWAP. Change the level to high. So now I'm going to enter my mail address, and this time I will send a reset code. Open Mailinator. Go to Inbox. Here's the latest mail. So as you can see, this time there is a link attached with a reset code. But now go to phpMyAdmin, refresh the page. The reset code is stored in the users table in the corresponding user column. Okay, so now click the link in the mail, and it will send us to a change form, and then we can change the secret. So for this kind of option, of course, yes, the mechanism works well. But for instance, there's no timer for the reset code, right? Also, the reset form is not protected against brute force attacks. There's no CAPTCHA protection. Okay, so open up your terminal now, display the page ba_forgotten.php, and it takes the email from the user. And then after validation, it queries the user table with this email. And if the security level is low, it just prints the secret. If the level is medium, it sends the secret in clear text to the user. And then on this line, when the level is high, it creates a random string. And that is the reset code for the end user. It creates a link containing the reset code. Then it sends it to the user. All right, so in this lesson, we analyzed some really bad implementations of password forgotten functions. Now, of course, in the real world, you will face some others. You will face those, though, too. But I think you get the point, right? And you know where and how to look. CAPTCHA problems. So CAPTCHA stands for Completely Automated Public Turing Test to tell computers and humans apart. Bet you didn't know that, did you? So basically, it's implemented to distinguish users and any entity that makes automated requests. So there are several CAPTCHA types, such as visual, oral, arithmetic, and so forth and so on. But the most known ones of these is the visual one. So many times, CAPTCHA is an image. It contains a human-readable text or maybe some numbers or recognizable image the user must solve in order to prove he is not a bot. And boy, doesn't it feel good to know that you're not a bot. So CAPTCHA is not an authentication control, but by using a CAPTCHA, it can be a very efficient way to mitigate against the enumeration of attacks and any process that's submitting that can be automated within a web application. So CAPTCHA images don't protect against a pure brute force. They can just put a layer of complexity over the form on which they are added. So that means that you can generally see CAPTCHAs implemented in login, registration, as well as reset and forgot forms. So this will barely protect against account takeover, username enumeration, and fake accounts creation. But let me show you this. So open up Kali and log into BWAP. And from the drop-down menu, open CAPTCHA bypassing. And this is the CAPTCHA-contained authentication form. So this time I'm going to do only high level. So change the level to high, and there's no difference in the view. Okay, so let's see the page source and see if there's anything interesting. So this is the form that contains a CAPTCHA, and the CAPTCHA image is included in an iframe. The source page is a CAPTCHA box, and this page contains the produced CAPTCHA image. Okay, so now open Burp in interception mode, and I will make the browser have a better view of the screen, and now we can enable Foxy Proxy. So now we need to understand the behavior of the form and the CAPTCHA. So there may be an implementation problem here. Okay, so I'm going to enter the right values into input fields, B, bug, and the CAPTCHA text. And, well, the request is in Burp. So forward it. And here's the response. Now let's have a look at the response. It contains a successful login message. Right? So this message comes up when everything is correct. So forward it. And now after we get the response, a CAPTCHA contained iframe sends the request to get a new CAPTCHA image. And the source of the iframe sends a new request to the image page. And the new image is presented on the page. So this new CAPTCHA image request will always perform the exact same way. So now let's try the wrong login information. Write CAPTCHA text. Forward the request. And now look at what we have. A new message. And this time only the CAPTCHA was true. Okay, so forward it and the rest. And now the true login information, and type a wrong CAPTCHA text. And a new message appears. It says incorrect CAPTCHA. And forward the rest. Now this time I'm going to fill in all of the fields with wrong values and forward the request. Let's look at the message that comes back. Incorrect CAPTCHA. So we can understand that it first checks CAPTCHA, then the login information, right? And forward the rest. All right, so now we're ready to shape our attack. So I'm going to perform a replay attack, and I'm going to get a CAPTCHA image, and then I will try further requests with it. So I will assume that I don't know login credentials and created a dictionary file before. And I fill the form with the correct CAPTCHA and send. Now the request is in Burp. And before forwarding it, send it to Repeater and Intruder. Then forward it. And look at the response. So the application checks the CAPTCHA, but the credentials fail. So forward it to the browser. Okay, so now we're at the critical point. I'm going to drop this new CAPTCHA request. So there are no more requests after this. Now open the Repeater tab and send it again. And the response still says invalid credentials. That means that the CAPTCHA is still valid. So let's prove it one more time with false credentials. And sure enough, still the same. Okay, so now go to the Intruder tab. I've already told you about these tabs, right? So go to the Positions tab, clear the parameters, and add username and password as parameters. Then the attack type is cluster bomb. And here we have just a 2 payload set, one for username and one for password. Payload set 1 is a simple test. Click to load the word list that we created in a previous lesson and choose it. And do it for the payload set 2 as well. So now open the Options tab. You don't need to change anything here, and scroll down to grep match section. Now clear these inputs. Now we need to provide a message to differentiate the successful logins. And that message happens to be here. So copy that. Then add it here. Okay, so give me a second to have a look, see if we missed anything. No, I don't think there's anything that we need to configure anymore. So if you're ready, I'm ready. Let's start the attack. And the requests start to list in the attack window. Let's wait for it to finish. All right, so our base request is just like that. And the associated response, as you can see. So now let's go to this line. Look at the response, and sure enough, we are successfully logged in. Okay, so now let's see, because we can quickly check the code. So let's open up your terminal and view CAPTCHA bypass. It's a whole page. So this line checks the security level. If the level is high or medium, then it will execute the following lines, which compares the CAPTCHA value sent by the user and the value in the session variable CAPTCHA. And as you can see, there is no code to assign a new value to the CAPTCHA variable in session. So you see, this is the main problem. This new value adds in a separate request. And that's what helps us to replay the correct CAPTCHA in the session variable. Path traversal. Web applications sometimes require reading from or writing to a file system. So by crafting parameters that reference files on the system, it's possible to access other files that are stored on the server. So a path traversal attack may enable us to read sensitive data, including passwords, application logs, and so much more. And we can view security-critical items, such as configuration files and software binaries as well. Now, if we're really good, we're able to navigate out of the web root folder, and then we can perform path traversal attacks. So users should only be restricted to the web root directory. Okay? And they should not be able to access anything above the web root. Now, the most basic path traversal attack is using the .. to move up one directory. Now, most web servers have been locked down to prevent this attack, but you never know. Some will still accept it. Okay, then, so let's go to Kali. Log into BWAP. Use the drop-down menu and open Directory Traversal directory. Now, there's nothing strange on the first page at first look. But look at this. See, when you start to pay attention to the URL, the directory parameter in the URL can reveal something. So let's delete this value. So the warning, this directory doesn't exist, appears. Okay. This means the parameter takes the name of the folder on the file system and prints the content of that folder. So now we can guess folders generally residing in applications, such as JavaScript, images, style sheets, and of course admin. Ooh, it works perfectly. Okay, so then we can try to traverse in the directories now. So for this, we need to climb up in between folders. Now, I know that the back end is Linux, and so that means I'm going to use Linux file systems placeholders to traverse between folders. So first thing to do is print what's inside the current folder, and the application executes the placeholder for the current directory. And look at the documents and folders under the current directory. Right, so we are still in the current directory. Now, climb up one level using this placeholder, and it works. Climb up one more level again, and climb up one more again. I think we should be in the root directory now, but we can try to climb up one more again. All right, so climbing up is done, so now it's time to traverse. View the home directory, and these are the user's home directories. So we'll go to B's folder. Okay, so go to Documents, and view the Scripts folder. And here are some scripts that run over the system. So in a situation like this, you can view many important files and configurations, right? In Path Traversal, I generally go to the etc directory and show password file. But this vulnerability these days works really only to view the content of the folders and not the files themselves. Okay, so anyway, let's change the level now to medium. Okay, and put the current folder placeholder to check traversing. And of course, we get a warning. We are detected. So let's see if that means that we also cannot climb. Okay, so sadly, that's true. Climbing's fun. But what happens if you just try a /? Oh, that works. Okay, so it prints the content of the root directory. I think the developer is escaping the dots. So we can check the code later. Right now, let's go to B's folder. And that's nice. This way we can traverse between folders. And now let's change the level to high. So delete the current value. An error message appears. That hasn't stopped us before. So let's try to climb and traverse. Okay, so that's not working. So now let's go and view the code. So view Directory Traversal 2 page and scroll down to code. So here's a function called show directory, and it has a directory parameter. Check and see if the directory exists. Show the content of that directory. Scroll down a little bit more. And the directory parameter in the URL passes to the show directory function. So if the security level is low, show directory function just executes. If the level is medium, the parameter we provide from the URL is checked with directory traversal check2 function. And for the high-level directory, traversal check3 is used. All right, so now let's have a look at these two functions. So let's scroll down to the functions that we're searching. All right, so here's the last one. That's why we are restricted to web root directory only. All right, so now let's go to the other function. And it checks for placeholders that we use to climb and traverse. All right, so you get the idea. You can always analyze the code more line by line by yourself. Okay, so another type of directory traversal allows us to read the content of any file. So with these such bugs, we need to climb and traverse between folders again. So we'll go to Kali and log into BWAP. Open Directory Traversal file from the menu above. And here's a sample page. Now, as you can see, there's nothing with the page itself. So this means that you've got to pay attention to the URL, just like the previous lesson. Now, it's easy to guess that this time the application displays the content of the file, passes page parameter, right? And call the magic file /etc/password. And here's the content of the file. See how perfect this is? So now we can try to climb to reach that same file. Climb up one more level. Nope. Then climb up more again. Nope. And climb up one more level. Oh, there it is. So for this kind of traversal attack, we can use a tool in Kali called .own. Now, it's very easy to use, but first we do need to capture the request. So enable Foxy Proxy, then open Burp in interception mode. I'm just going to rearrange the screens for a little better view. Okay, so now refresh the page. And here is the request in Burp. So now I'm going to change here to the string Traversal and copy this request to a file. And let's call it dt.txt and save. Okay, good. So now go to your terminal, simply type .pwn, and we'll look at the options. And the options are very clear. So let's run .own against BWAP. Type .pwn m payload. So the m parameter is used to specify the module. Now, because we're going to use the burp output, we should choose this module. And then h for the name of the host. And p for the burp's output file. Unix, you can use this parameter if you know the target operating system. It's not necessarily necessary. And etc password. So with this, you can look for a specific file on the target file system. I told you earlier, I like the password. D3 to specify the depth of the payload. And X80, and that specifies a port number. So finally, B to quit after the first vulnerability is found. Okay, so now we can hit enter. Oh dear, something went wrong. Let me just have a look quickly. And okay, yeah, so I forgot to add a parameter, the parameter K. So add K root to make the tool understand if it is able to read the file content or not. Okay, then go. And it discovered the traversal. And as you can see, it detects the same way we do. 3 consecutive climbs. And now I'm going to exclude the parameter B. So this time it's going to discover as many payloads as it can. All right, so it finds 3 different versions of payloads. Okay, so then go to the web browser again. Disable Foxy Proxy. And now change it to a medium level. So I'm going to add the path that we used before. Okay, so it doesn't work. Okay, so I can delete the first 2 placeholders. And it works pretty well, huh? And for the last level, I'll add the same payload, and it doesn't work. Okay, so to be honest, I was waiting for this result. I'm not surprised, but I want to, I set it up on purpose, obviously, but I want to show you another trick to use here. The file protocols. So type file : ///etc/password, and there you have it. Okay, so I want to show you the vulnerable code as well, but it really isn't actually very different than the first one, so I'm going to leave it for you to look at. All right? Cool. Good job. File inclusion attacks. Now, in web applications, developers sometimes can include files stored on local or remote servers. Referencing files other than the ones in the web root may cause a full system compromise if the server software executes the included file. So in this section, we are going to discover some file inclusion vulnerabilities. There are basically two types of file inclusions, local or remote file inclusion. The local file inclusion comes out when the user accesses a local file out of the web root directory, and the access file is included in the execution environment of the web application. And the remote file inclusion comes out when the user includes a remote file into the execution environment of the web application. So that way the included file is going to be executed with the actual content and served up to the user. Now, besides being an authorization problem, some people can categorize path traversal and file inclusion vulnerabilities as input validation problems. No matter how you categorize it, it is up to us to evaluate how these vulnerabilities work. So go to Kali, and I'm going to show a basic file inclusion. So log into BWAP. Then from the menu above, go to Remote and Local File Inclusion. Now you see there's a drop-down menu of languages. So when you choose a language in Go, then the URL is changed to this. So then a language parameter is added with the value of the chosen language. But this value seems to me to be a page, lang_n.php. Yeah, so this is suspicious. So the application can load a language file when a user chooses that language, you see. So for us to benefit from this, maybe we're able to load another file on the system? What do you think? Well, let's go and enable Foxy Proxy, then click on Go. Okay, so now go to Burp, and the request comes to Burp. But before forwarding from the action button, let's send the request to the repeater tool, and then let the request go. Now open up the repeater tab. All right, so here's the request. So send it to the server, and it executes without any problem. So let's try to read the magic file on Linux. So instead of this PHP file, type /etc/password and send the request. Okay, so now let's look at the response. Here's the result. We can read a file out of the web root directory. Now, change the cookie security level to medium. Okay, set this to 1. And the same request. So it doesn't work this time, but look at the error, because it appends a PHP extension to the end of the file that we provided. So we need to get rid of this extension to read the file content. And we do have a little trick for that. You want to know? All right, so just add a null byte to the end of the file, $00, and add the request. And scroll down and see the response, and the content of the file is here. All right, so now clear it here and go back to low level. I want to show you another payload. So sometimes PHP wrappers can help us read a file on the system. So PHP comes with many built-in wrappers for various URL-style protocols for use with file system functions. So what I'll do is I'll just add a PHP filter here, php://filter/resource equals /etc/password. And the response has the file content. Yeah, so when you want to read a special file type, such as PHP or XML, it will break the execution. So in these types of situations, you can encode the file if you want to view it. So now I'm going to paste this payload here, and it'll convert the file to base 64, send the request. And what you see here is the response has the base 64 output of the file. So I'm going to copy just that part and open Decoder and paste it here. And then decode as base 64. Okay, here is the content of the password file. Now, you may wonder, well, what's the difference between the path traversal and the local file inclusion? Yeah, many people on the surface might confuse the two, but I'll tell you that in a path traversal flaw, the application will only read the contents of the file or directory and then display it. But in a file inclusion flaw, instead of displaying the content, the application will include the file as if it is an executable script, and then execute it with the same privileges as the web application. So I think that's a pretty big difference, and it's, the most evident difference between the two, but they're both very useful. Okay, so let's exploit them then in this way. For a fresh hack, you can start over, but I'm just going to move on with the same request. So there are several ways to include a file which is stored local or on a remote server. And also there are several ways to execute the files that are executable. So the first way is to contaminate the log file, then include the contaminated log file into the page. Okay, so just send the first request, then go to bbox, open terminal, and type tail/var/log/apache2/access.log. So this log file contains the get requests that we sent. So now I'm going to contaminate this file with a PHP script. So going back to Kali, I'm going to paste this PHP code, and it's a simple PHP shell. It'll execute the value of a command parameter sent over the URL as an operating system command, and send the request. There's nothing with a request, so go to bbox, run the same command in terminal. So here is a PHP code that we sent over URL. Now go back to Kali and delete this code and type /var/log/apache2/access.log &command equals pwd. All right, so no, it doesn't work. The command is not executed. We got a permission denied error. So that just means we need to try something else. Now, there is a special file in the directory /proc/self/environ. Now, in order to contaminate this file, we need to add the simple PHP shell as the value of the user agent header. So I'm going to paste it in here. Now send the request and have a look at the response. No, it doesn't work as well. We got the same error. So, okay, we can try it a different way. I need a clear request, so I'll go back. And I will change this payload to a PHP wrapper this time. So let's add php://input here. And now paste the PHP shell script to the body of the request, like this. All right, so now send the request and look at the response. That's it. Yeah, this time the command works. And okay, so change to the list command. And it works. So now let's go a little further and open a netcat shell in bbox. So the first thing that we need to do here is we need to learn where the netcat binary is. Sometimes it can reside in different directories, so it's not too hard to find. Just type which %20 in C. %20 is the URL encoded space character, and send it. And here is netcat under the bin directory. And here are the bash commands to open a reverse shell from bbox to Kali. So now I'm going to copy the second one. Now sometimes it doesn't work because of the difference between the versions of netcat. So your version and the version on the target may cause problems. But in a situation like that, you can always use the third line as the reverse shell. Okay, so I'm going to paste it here and send it. I think something went wrong. I don't see a response. There's nothing in it. Okay, so I found it. Yeah, it's for sure a URL encode problem. So let's open up the decoder tool, paste here, encode as URL. Okay, copy all of that wild output and paste instead of this. Now, before sending the request, open terminal, and of course we should listen for the incoming shell connection, and C-NLVP443. Now, go to Burp again. Now send the request. Now, I wait for this empty response pane in a previous attempt, so I think we get the shell. Go to terminal, and here's a connection IP address of bbox. So this way, netcat provides us a shell interface on bbox. So now we can execute the bash shell commands on bbox. ID to see the current user, and you can execute every command that your user is able to execute. And what do you know? We can traverse between folders, list them. Now, from here on out, it's up to you and your imagination. What can you find? We are going to exploit the remote file inclusion in the next lesson. All right, so in the previous lesson, we exploited the local file inclusion. And we got a shell from the target. And if there are no extra checks, including a remote file into the current page is also very possible. So in this example, we're going to use the same page. Here's the language parameter in URL. And it's very easy to validate if the application is akin to RFI. So delete this here and write a website's address. I'm just going to use imdb.com. And in just a moment, it'll appear. And yes, indeed, this is the RFI. So now let's think of how we can take advantage of this. What do you think? All right, so let me lead you down the garden path. Open your terminal. List the files in the web root directory of Kali. Now see, I have two files here. So let's restart the Apache service. And sure enough, Apache is running now. So what do you suppose the plan is? I will serve a page on my local server on Kali, and then I will include that page into BWAP. So I started the Apache web server. So then let's go to the browser again and change the language parameter to http://192.168.204.128/index.html and go. Okay, so the index page is displayed by the application. So now instead of this page, we can provide a PHP shell. So go to terminal. Now, Kali has some web shells to use in these wonderful situations, and you can view them just like this. Now I'm going to use the PHP version of shells. So copy both the PHP backdoor and the reverse shell and paste it into the web root directory. So go to the web root directory. And the PHP files are here. So I'm going to use PHP backdoor first. So let's view the code to see what it is. Yeah, it's a little bit hard to read the code, but yeah, there's nothing to change here. So exit and go to the browser. And type http://192.168.204.128/php-backdoor.php and go. Yeah, so BWAP loads the remote page on Kali. So this is a sample shell. It also has a few bugs, but the upload feature is great. So let's browse to upload a file. I choose this one and type here the directory to upload the file. Upload admin directory. And I think we've already uploaded, so go to bbox. List the admin directory. And there is the uploaded file, as you can see here. So this can be any executable as well. Okay, you don't believe me? Go back to Kali. Now use the PHP reverse shell. And let's view the code. So I think this code is a little bit more readable than the previous one. But we do have something to change here, right? It's at the beginning of the file. So change the IP variable to IP address of Kali and to the port, to any port that you want to listen. For example, let's choose 443. And there is one last thing to do. Change the extension to a text file. Because sometimes the content of the reverse shell can be truncated. So to be sure, we can change. But sometimes, I try it without a change and it works as well. Okay, sorry, that might be a spoiler. So remember to restart Apache. And before leaving terminal, I am going to start Netcat Listener on port 443. So I just go back to the web browser and call this shell. I think the shell is included. So go to terminal. And here's a pretty bash shell. And you can type bash commands. All right. So that's a lot of fun, and you can have a lot more fun with it. But for now, we are done with file inclusion vulnerabilities.